Okay, moving on to example 2, solving nonlinear systems by substitution. So recall, substitution method is about taking one equation and solve for x or y, and then take it and plug it into the other equation. So looking at these two equations, it would make sense to solve for the first equation, either x or y, and take it and plug it into number 2's equation. So I'm going to choose to solve for x. I'm going to take the first equation. What do I need to do there to solve for x? If you said add y, then that is correct. All we need to do is add y to each side. We've already solved for x. Now, we're going to take that and we're going to plug it into the other equation, which is number 2. And we're going to plug it in x's place or in y's place. Which one? Yes, we're going to plug it in x's place because that's the variable we solve for. So into equation number 2, I'm going to remove the x and replace it with y plus 3. When we do so, it's going to look like so. Next, I need to order of operation, combine what's inside the parentheses. So a positive 3 and a negative 2 is going to give me a 1 there. We have two binomials here, and we want to solve for y. So we need to get all of our terms together. So you could put them side by side and FOIL. That means you have two of the very same binomial terms. You can do that and FOIL, or you can do the binomial square binomial method. Okay, I'm going to do the square binomial method on the side because I think it's so cool. So here, let's get let me get something to write with here, and I'll start with the first one. That's y. Oh, it's kind of hard to write with this mouse. Plus 1. Okay, as I said before, it means you have two of the very same thing. You can put it together and do FOIL, but I really like the square binomial method. And what that method says is square the first term. So when I square y, y times y is y squared. Square the second term there, the last term. So 1 times 1 is 1. Which, by the way, the last term will always be a positive. It will never be a negative. The sign of the middle term is determined by what's inside the parentheses, so that's a plus. To get your middle term, multiply the number 2 along with these terms. So that would be 2 times y times 1, and all that together equals 2y. And that's how easy it is. That's the square of binomial method. I'm going to do that for the next term so you'll see what it looks like. Y plus 3 squared means you have two of the same thing, but we're going to use the square of binomial method, which says square the first term, square the last term. 3 times 3 is 9. The last term is always positive. This sign determines your middle term. To get your middle term, multiply the number 2 along with both terms that are in the inside. So 2 times y times 3. When you multiply that all together, that's going to give you 6y. And there we've solved that using the square binomial method. Okay, so once you do that, here's all those terms, and that's exactly what we got there. You're then going to combine like terms. So combine your y's. 1y squared plus 1y squared is 2y squared. combine your first degree terms. 2y plus 6y is 8y. Combine your constants. 1 plus 9 is 10. All right, so once we combine all of those terms on the left, we'll have a trinomial. We want to solve for y, so we need to get all of our terms on one side. So let's again utilize that zero factor property, which means everybody on the left and 0 on the right, which means I'm going to subtract 4 from each side. Continuing on with the zero factor property now, instead of trying to factor this into two binomials, I see here there is something that all terms share in common. So we need to take that GCF out, greatest common factor, because there's a 2 inside each term. So let's go ahead and take the GCF on the outside, everything else left in parentheses behind it. And now we are going to factor that trinomial into two binomials. Continuing on with the zero factor property, take each parenthesis, set it equal to 0, and solve for x. We can do mental math to see that here we would subtract 3, which means y would equal -3. We would subtract 1, y equals -1. Now the 2 is not part of your solution. Remember, in order for it to be a part of a solution, it must have a variable. You can't solve for y if you don't have a y. So that 2 is not part of your solution. It is only the -3 and the -1. Now we're going to take those two solutions and plug them back into equation number 3. You're saying, well, where's equation number 3? I mean the one that we solved for at the very beginning. Because we solved for x at the beginning, and that's what we're looking for. We already know what y is. We need to find out what x is. So it would make sense to use that equation that we solved for x at the beginning, because once we plug in our value to the right, you will know what x is. So let's begin. We're going to remove this y and replace it with -3. When we do so, we can right away see that x equals 0. When we do so with the other term variable being -1, removing the x and removing the y and replacing it with -1 so that we can find out what x is, we can readily see that x equals 2. So when plugging in a -1 for y, what we get out for x is a 2, and these are our two solutions. Remember, if you're not sure about your solution, you can always plug it back in. When you plug it back in, if it leaves you with a true statement for both equations and both solutions, that is your proof that it is indeed your solution. And here is what a graph of your solution looks like. Remember, the points of intersection illustrates the nonlinear system solution. Our graphs intersect at 0, -3, and at 2, -1. Therefore, those are our solutions.